does a rotation affect the properties of a two-dimensional figure? Think about this question during the lesson. One feature of the new patio plan is a rectangular umbrella that can easily rotate so that clients can enjoy either the sun or the shade. Where should the architect move the umbrella to highlight this feature for his clients? We want to show a rotation. How can you describe the rotation of the umbrella? A rotation is a transformation that turns a figure around a fixed point, called the center of rotation. The angle of rotation is the number of degrees the figure rotates. A positive angle of rotation turns the figure counterclockwise. The umbrella has been rotated about its center. How many degrees did the umbrella rotate from its original position?
Select your answer.
The architect rotates the umbrella 90 degrees counterclockwise about its center. The umbrella has the same size and shape. Now you know how a rotation affects the properties of a two-dimensional figure.
The architect continues to rotate the umbrella in a counterclockwise direction until it is in its original position. What is the angle of this rotation?
It is a 90-degree angle, and it's going counterclockwise. So it's still going to be at that 90-degree angle if he continues to turn it from that position. So since it's still 90 degrees each time it turns counterclockwise, it says if he is continuing from that direction, so 90, 90, 90, that's 3 more times he's turning it. So the angle of that single rotation, if he goes all the way from here to there, will be 90 plus 90 plus 90, which is 270 degrees would be the rotation.
What are the coordinates of the image of trapezoid ABCD after a 90-degree rotation about the origin?
Step 1, draw a ray from the origin to point D. So you see how they have the orange 90-degree ray there. Then use a protractor. We don't have a protractor, but you're going to turn it counterclockwise. And you plot point D the same direction from the origin as point D. So they took it, and when they rotated it, that's how you get this second ABCD over here. And so you use that same method to map the vertex of trapezoid ABCD to its image. So that's what it looks like after rotating it 90 degrees. And here are the coordinates for each of the vertices.
The coordinates of the vertices of quadrilateral HIJK are H 1, 4, I 3, 2, J -1, -4, and K -3, -2. If quadrilateral HIJK is rotated 270 degrees about the origin, what are the vertices of the resulting image? Quadrilateral H', I', J', K'.
Okay, and remember those primes is after you rotate it. So it's the same shape, but after the rotation. So now it's asking if we rotated this 270 d degrees about the origin. What are the vertices of the resulting image? Okay, so for sake of imagery, I'm going to draw a quick picture because it's not going to be exact. Let's see, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so I'm going to graph the original HIJK. So H is 1 and 4. That's H. And then I is 3 and 2. Keeps trying to zoom. Okay, so this is I. And then we have -1 and 4. So -1 and -4. That is J. And then we have -3 and -2. -3 and -2 is right here. Okay, again, this is not exact. This is from a quick picture. So I'm going to connect the dots so we can see. This is our quadrilateral. Okay. And it says if it is rotated 270 degrees about the origin. Alright, so it doesn't say counterclockwise, so we're going to assume it's clockwise. Let's see. So here's our origin, and so we're going to twist or turn this quadrilateral 270 degrees. So remember that's 90 degrees. So that's 90, 90, and 90, right? That's 270 degrees. So if we turn this rectangle or quadrilateral like that, we would be, let's see, if we follow the example and turn this counterclockwise, then we'll be going this direction, 270 degrees about this origin. So if we turn this, and again, I'm not using a protractor per se, but in the example, they gave us a generalization of how the coordinates will look, and I'm just going to rewrite it here on the side. So the angle rotation is 90 degrees. It said that the rule would be if it started in XY, it would be negative YX. If it were 180 degrees, it would be XY, and it would go to negative X, negative Y. And if it's 270 degrees, then it would be XY, and it would be Y, negative X. So with the rule, we would be looking at the one that says 270 degrees. So we're going to look at this one. So if we look at this one, that means that our I'm going to take H. It's going to be the point that I'm looking at. So if it's in X, Y, positive X, positive Y. If I rotate that counterclockwise, 270, my Y should be a positive, and X should be positive and the Y should be negative. So, well, no, it says Y and then negative X. So that would mean that my new H is 4. My new H would be 4. New I, and I'm following the rule, my new Y would be 2 and negative 3. My new J would be 4 and still, it's already negative 1, so it'll be positive 1. And K would be, I'll put K up here, I don't have space. So K would be 2 and, well, negative 2 and 3. Okay. And again, I did not use a protractor. I used the rule that was given to us from the example.
Describe the rotation that maps parallelogram A, B, C, D to parallelogram A prime, B prime, C prime, D prime. The first step is to draw rays from the origin through point A and point A prime. Next, measure the angle formed by the rays. The measure of the angle is 270 degrees. A 270-degree rotation maps parallelogram A, B, C, D to parallelogram A prime, B prime, C prime, D prime. What is another way to describe a rotation of 270 degrees? A rotation of 270 degrees could also be described as a rotation of negative 90 degrees, or 90 degrees in the clockwise direction.
Describe the rotation that maps triangle FGH to triangle F prime, G prime, H prime.
Okay, so it says drag the green points to choose. Alright, so if I drag this, boom, it says that is, there we go, 180 degrees. Okay, so that rotation was clockwise, 180 degrees.